The System Development Corporation has underway a research project to synthesize behavior at the instinctive, pre-programmed level. The Philco 2000 computer, shown here, has been used to simulate a robot interacting with its environment. The organization of the robot's programmed decision-making and control functions is patterned upon a theory of functional organization of instincts within the central nervous system. This theory, developed by an investigator at SDC, has been deduced from ethological observations of instinctive behavior in animals and experimental neurophysiology. The robot's behavior, as calculated by the computer, is displayed on this scope. Instructions and information are introduced to the computer by this device known as the RAND graphic input tablet. This stylus, when placed on or near the tablet, causes a spot indicating stylus position to be displayed on the scope. When pressed down on the tablet, a switch in the stylus closes, enabling different programs in the computer to be executed according to the stylus position at the time. This is the starting position of the robot called a droid. This is the outline of the robot. This is the robot's arm, and these lines define the robot's field of view for its single eye. This is a prime target to be used as nest-building material. Now we press the button labeled Go in the lower left-hand corner. This causes a new row of what are in effect push buttons to be displayed on the right. D is for a display function. By pressing it, new row of push buttons is displayed on the right. By pressing various buttons, we may introduce an environment of obstacles and nest-building materials to be manipulated by the robot. First, we press the button labeled M in order to move the nest-building material. Then we change its size slightly. Next, we introduce obstacles in the path between the robot and the desirable nest-building material. Now we designate a nest site by the large X. The robot's task is to first find a suitable nest site, designated by a large X, and then gather suitable prime targets to build the nest while avoiding obstacles that may be present. To start the robot on its task, the little X in the upper right-hand corner must be pressed, returning us to the previous set of push buttons. By pressing the G in the lower right-hand corner, the robot is activated. The robot first searches for a nest site. When this is found, it seeks for nest-building material indicated by the object with the P. This is seen immediately, and a droid starts out for it, searching for an opening in the row of obstacles. The flicker you see is due to the computer cycle between successive decisions to either advance or rotate by a small increment. When a droid arrives at the target, it places the target on its back before searching for the nest site. After finding the nest site, a droid goes to it and places the material with respect to the nest site center defined by the large X. Once this is in position, the X disappears. A droid discards the X because it now adds objects with respect to material already placed. we intervene and stop adroit's search for a second suitable target in order to rearrange the obstacles and to provide another target. At this point, we introduce a second suitable object for nest building. Now we restart adroit's operation. Here we see an example of a mistake in program logic that produces a decision to go the long way around an obstacle. This mistake has since been corrected. Adroit now places the second object. We stop program operation to place a third object. Now we intervene to put a fourth object in place in the growing nest structure while adroit cannot see it, behind its back as it were. we see that a droid places its object correctly next to the one introduced by us. We stop a droid to place another object. As it sets out for the fifth object, we place a sixth directly in its path. A droid reaches for the new object immediately, substituting goals appropriately. The droid finishes the nest and searches its executive for another task command. Finding none provided at this stage of our program, it halts. In the near future, we expect to program other activities to illustrate more complex instinctive behavior patterns of animals.